Hello everyone. In today's class, we are going to start with the second chapter of physics, units and measurements. What is a measurement? Measurement is a process by which we measure a physical quantity using a specified instrument for that quantity. For example, we have scale to measure length, clock to measure time, balance to measure mass, thermometer to measure the temperature. These are the examples for your measurement. Why do we need measurement? By measuring a physical quantity, we can outline the property of a material with which a physical quantity is related with. Example, length, mass, time, temperature. Let me give an example. If you go to a doctor, imagine you go to a doctor, okay, and he has to check whether you have fever or not. Without measuring your temperature, can he find out whether you have fever or not? No, he cannot do it, right? Similarly, when you have to go to meet a doctor, right? If he doesn't let you know what is the time at which he'll be available, would you be able to go and attend the doctor's session? No, you won't be able to attend the doctor's session. Similarly, without measuring your mass, can your doctor make out whether your diet is right or not? No, he cannot make out. So basically, what I am telling, we need measurement everywhere in life, right? And this is just one example which I have taken. And measurement helps us in easing things for us, right? It eases things for us. That is the reason why we use measurements. Physical quantity. Physical property of a body that can be measured is called a physical quantity. Examples of physical quantities are mass, length, time, pressure, area, volume, temperature, current, velocity, density, etc. Right? Anything that you can measure is called a physical quantity. Next, we have something called unit. To measure a physical quantity, so physical property that can be measured is called a physical quantity, right? To measure a physical quantity like length, mass and time, we require a standard of measurement. This standard of measurement is called unit of that physical quantity. For example, unit of length is meters. One of the unit of length is meters, and the standard of length of 1 meter has a precise definition. We know what is 1 meter already, right? Using that, we can measure what is the length of any object, right? Similarly, what are the other units of length? We have many other units of length also. Meter is one of the unit, right? We have centimeters, we can have kilometers, we have millimeters, inches, feet, all are your units of meters, right? Units of length, I'm sorry. SI unit. I was just talking about units of length, and I told you there are many units of length. Similarly, for your time also, you have many units of time: second, hour, days, or you can even take years, months, fortnight, anything you can take as a unit of time, right? Now, we require a single unit such that our communication becomes easy. Now, what if I use a unit of my choice and the other person uses the unit of his choice? The communication becomes hard. So, how do we solve this problem? So, there comes your SI unit. The International System of Units, sometimes also known as SI system, is a modern form of world's most widely used system of measurement. So this is the most widely used system of measurement, and for a particular physical quantity, for every physical quantity, we will be having something called SI unit, which we will be seeing in the coming slides. Types of physical quantity. Physical quantity can be categorized into two parts, or you can say two groups. One is fundamental quantity, the other is derived quantities. The physical quantities which do not depend on other physical quantities for their measurements are known as fundamental quantities. The physical quantities which depend on other physical quantities for their measurement are known as derived quantities. There are only seven fundamental quantities which I have shown in the table. Next, we have SI unit, and we also have the symbol for that. So there are only seven fundamental units. The first one being length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Only these seven are your fundamental quantities. Rest everything will be your derived quantity. Now, we have SI unit for each of the fundamental quantity. For length, we have meters and the symbol is M. For mass, it is kilogram, the symbol is kg. For time, it is seconds, the symbol is S. For electric current, the SI unit is ampere, the symbol is A. For temperature, the SI unit is Kelvin, the symbol is K. For amount of substance, the SI unit is mole, the symbol is also mole. For luminous intensity, the SI unit is candela and the symbol is C. Okay, next, derived quantities. What are derived quantities? I told you that derived quantities are the quantities which depend on two or more fundamental quantities. So I have few examples here: area, volume, density, speed, acceleration, and so on. There are many examples for your derived quantities. However, we have only seven fundamental quantities. Now, let us take an example of velocity. Let me show you how this is a derived quantity. What is velocity basically? Velocity, can I define it as displacement divided by time? What is displacement? Displacement is nothing but the measure of length, right? What we are doing there, we are just measuring your length. So I can write your length divided by your time. Now you can observe that length is one of the fundamental quantity and time is also a fundamental quantity. So I can tell that velocity depends on two fundamental quantities. That is why velocity is going to be your derived quantity. Okay. Similarly, we can take for force also. What is your force? We know from Newton's second law that force can be written as m into a. What is m here? M is nothing but your mass, right? Mass into acceleration. What is your a? Acceleration, can it be written as your velocity divided by your time? What is velocity? How can you write your velocity? We have already seen here velocity can be written as length over time, right? Excuse me. So I can take mass divided by this time over here multiplied by velocity is length over time, length over time. We observe that force is dependent on mass, length, and time. So, three fundamental quantities are there, or force is dependent upon three fundamental quantities. That is why I can consider force as a derived quantity. Okay, I hope the example for your derived quantities or how to categorize any quantity as fundamental or derived quantity is clear. Types of units. We have two types of units. One is fundamental units, the other one is your derived units. The units used to measure the fundamental quantities are called fundamental units. What are the example? Meter, second, kilogram, Kelvin. Basically everything given in this particular table. Fundamental quantity, all these units are going to be your fundamental units: meter, kilogram, second, ampere, Kelvin, mole, and candela. Again, you have only seven fundamental units. Coming to your derived units, the units used to measure derived quantities are called derived units. What are the examples for these? The examples for these are meter square, meter cube, kg per meter cube, meter per second square. Any two or more units if you have, or fundamental units if you have, that is going to be a derived unit. Apart from your 7 fundamental units, you have 2 more units that is categorized under supplementary units. First one being the plane angle, the second one being a solid angle. Let us see what is a plane angle. If we consider a radius, or if we consider a circle with a radius say r, let the radius of the circle be r and the length of arc, meaning that, let me just highlight it over here with the green marker. So this length, so this is called your length of arc. This let us represent by s. Okay, now the ratio of the length of arc to the radius of the circle is known as your plane angle. So if I consider this angle to be theta, what is this theta? It is defined as the ratio of your s divided by r, meaning the length of arc divided by the radius. Now the SI unit of the plane angle is radian, and I can tell that 1 radian, the angle is going to be 1 radian. We'll be writing 1c for radian. The angle is going to be 1 radian when s and r are both are equal. When the radius is equal to the length of arc, I can tell that the angle is going to be equal to 1 radian. Similarly, for the solid angle, if we consider a sphere and a cone is taken out from a sphere, the ratio of the area of the bottom of this sphere to the radius of the sphere is going to be called the solid angle, and solid angle is represented by omega, and I can tell that the angle is 1 steradian. The SI unit of your solid angle is steradian. So I can tell that the angle is going to be 1 steradian if the ratio of area and the radius will be equal to 1. Okay, I hope that is clear. So if the area, meaning that the ratio of area divided by the radius, if this is equal to 1, what does this mean? This means that the area should be equal to the radius. If that is the case, I can tell that the angle is 1 steradian.